All right, guys, we are continuing with section 7.6. We just looked at the solving exponential equations right here, and now we are going to move into the solving logarithmic equations right there. So hopefully you just finished that. You're moving on to this. We can still be in that same frame of mind. What I was really talking a lot about was that whenever you see like 3 to a power in log base 3, those are inverses of each other, right? 2 to a power and log base 2 are inverses of each other. If the base of the exponent and the base of the log match, we know that those are inverses of each other. They cancel each other out. So let's take a look at our first example of an equation with a log in it. We want to solve it. Your first step is to isolate the log. So in this problem, log base 3 is isolated. There's nothing on the same side of the equation as the log. Let's look at an example just for fun. Here's an example where the log isn't by itself yet. So that problem we'd have to do a step first. But in this problem over here, we only have a log. And so that's our first step. You see it's log base 3. Well, what undoes log base 3? Hopefully you're like 3 to a power, right? 3 to a power and log base 3 are inverses of each other. Now, what's kind of weird about this is going to be the first time we've seen anything like it. So track with me here. Log base 3 and 3 to a power are inverses of each other. The 3 is now the base, and this whole thing is an exponent. Big 3 to the power of log base 3 of 2x plus 2. Now, I'm allowed to do that if I do 3 to the power on the other side. So I did 3 to the on the left and 3 to the power of on the right, right? 3 to the log base 3 of 2x plus 2 and 3 to the power of 1. Well, we know what 3 to the power of 1 is. It's 3, right? This is not 3 times 1, just to be clear. This is 3 to the power of 1. This is the base. 1 is the exponent. Now, I'm allowed to do that if I do the same thing on the other side. 3 to the power of log base 3. Those are inverses of each other. They cancel each other out. 2x plus 2 is just going to be normal full size, and this is an equation I am able to solve. What do? I subtract 2 on both sides, and I get 2x is equal to 1, so x is equal to a half. If you notice, up here in my directions, not only do I say solve, but I also say check. One of the things that you need to know is you are never allowed to take the log of a negative number. I'm going to say it one more time. You're never allowed to take the log of a negative number. If you do, we've used this term before, that would be an extraneous solution. So every time, you don't actually have to verify that it works. You very well can. That's good practice. However, what you're making sure of is that when you plug this number in, a half in, would this statement in parentheses here be negative? Of course it would not. There's no negative numbers or subtraction or anything like that. So this is definitely going to be positive. Your solution will work. There are definitely going to be problems with extraneous solutions though. You plug the number in, and this number in parentheses here would have been negative. That's not allowed. Let's take a look at another example here. Log base 2 of 3x minus 4 is equal to 5. Now, I want to get rid of the log base 2. We know what undoes a log base 2. That would be 2 to the power of. Remember, 2 is now the base. This whole statement here is now an exponent. That's because 2 to the power of log base 2, those are inverses of each other. They're going to cancel each other out. But if I do 2 to the power of on one side, I also have to do 2 to the power of on the other side. We know what 2 to the power of 5 is. A bunch of people are going to say 10 because they're going to multiply them because that's what we're more used to doing, but 2 to the 5th power is 32. On the left side, 2 to the power of log base 2 cancel each other out. Just like addition, subtraction, multiplication, division. They just undo each other. They cancel each other out. That 3x minus 4 will just stay. It's no longer in the exponent. It's going to become full size. And this is an equation I can fairly simply solve for, right? We would add 4 to both sides. We get 3x is equal to 36. So x is equal to 12. Remember to check your problem every time, check your solution every time. When I plug 12 in, am I going to get a negative number here? No, I'm going to get 36 minus 4, that would be 32. Okay? You could take it a step further and do the change of base formula. Log base 2 of 32, do you actually get 5? You will. I already showed you guys this slide because remember, this problem you're going to have to do a step first. You are going to have to solve for log base 4 of 2x. I think you guys probably have a good idea of how to do this because we've seen these types of things for years. We want to get rid of this 5.2. That 5.2 is being multiplied. So of course I'm going to divide both sides by 5.2. Those cancel. Now I would have log base 4 of 2x is equal to whatever 16 divided by 5.2 is. And 16 divided by 5.2 is 3.077. Now the log base 4 is by itself on the left, and we happen to know what undoes log base 4. Hopefully you guys are catching on. You're like, well, 4 to the power of log base 4, so that would undo each other because 4 to the power of and log base 4 are inverses of each other. They cancel each other out. Therefore, we just have 2x on the left. And if I do 4 to the power of on one side, I also have to do 4 to the power of on the other side. So I can now do 4 to the power of 3.077. That would get 71.210. Dividing both sides by 2 would give you x is equal to 35.605. Once again, we have to make sure that when we plug this in, we don't get a negative number. We don't, so we're good. If you did get a negative number here or something, you just cross it out and say no solution. Would be a good place to pause. This one's fairly straightforward, I believe, and make sure that you are understanding this. I'm going to go ahead and proceed. Log base 2 and 2 to the power of undo each other, but if you do 2 to the power of on the left, you also have to do 2 to the power of on the right. 2 to the 6th power is 64. And 2 to the power of log base 2 cancel each other out, and you get x minus 4. Your solution, x is equal to 68. It does get a little bit harder here. It looks like it's not going to yet. These ones are going to be pretty nice for us, actually. I'm going to start with the one on the right. Log base 3 of 12x minus 11 is equal to log base 3 of 3x plus 13. Well, I know that 3 to the power of log base 3 cancels each other out, right? If I do that to one side, I can do it to the other side. Well, it actually works out pretty slick because the 3 to the power of log base 3 cancels out here as well as here. So I'd end up with 12x minus 11 is equal to 3x plus 13. And now this is a simple algebra problem. Subtract 3x over to get 9x is equal to 24. So x is equal to whatever 24 over 9 is, which is 2.67. We do have to verify that when we plug it in, we won't get a negative number. We're going to have to make sure that that's true for all logs because you're never allowed to take the log of a negative number. When you plug 2.67 here, that would definitely be positive, as would that. So we are fine. I skipped this one on the left just because I wasn't sure if you guys were going to be good with how to undo ln. It's really not more tricky. Same idea here. What undoes log base 3 is 3 to the power. Well, what undoes ln? Keep in mind, ln is just log base e. So what's going to undo ln of something? Well, e to the power of something. That'll cancel out, and on this side you have 7x minus 4 If you do e to a power of on one side, you'd also have to do e to the power of on the other. So you'd have 2x plus 11. I'm going to solve this now, subtract the 2x, add the 4, we get 5x is equal to 15, so x is equal to 3. Let's verify it. Works there, both of those would be positive, so 3 is a good solution. Now here is where things get a little bit more tricky. I think students, I see this wrong a lot when we are on the section. People are like, well, I know that 8 to a power undoes log base 8. However, I can't do this. This is not mathematically correct. Take 8 to the power of all these things. I need to have one log for it to undo. Okay, I can't have these two separate logs. So what we actually end up using is some of the stuff from the previous section, which was 7.5. What you need to do is you need to condense this. Condense it so that the word log is only written once. Hopefully you guys remember that when you are adding logs, that's the same as when you combine it under one log, multiplying these things, right? Addition turns to multiplication when you're condensing. So I would have to multiply 5x times x minus 1, and this is going to have to be something that we distribute. So our first step was to condense these, keeping in mind that when we add separate logs, we can condense them under multiplication as long as they have the same base, which they did here, base 8. Now we only have the word log written once. We know what undoes log base 8. That would be 8 to the power of log base 8. If I do 8 to the power on one side, I have to do 8 to the power of on the other side, and 8 squared is 64. 8 to a power of log base 8 cancels, and we would end up with 5x squared minus 5x is equal to 64. And this is still going to be kind of gross. We have a quadratic here, and it's not a very pleasant quadratic. We are going to solve this using the quadratic formula. When we use the quadratic formula, one side has to be set equal to 0. 5x squared minus 5x minus 64 is equal to 0. Here we go, quadratic formula. Negative 5 plus or minus the square root of negative 5 squared minus 4 times 5 times negative 64. Hopefully this is second nature to us at this point. I'm going to type that whole thing underneath the root into my calculator. Negative 5 squared minus 4 times 5 times negative 64 is 1305. So I have 5 plus or minus the square root of 1305 over 10. The square root of 1305 is 36.12. So I'm going to move it up here. 5 plus or minus 36.12 over 10. 5 plus 36.12 10 is 4.112. And 5 minus 36.12, dividing that by 10, is negative 3.112. That was quite a bit of work. We're not done yet either. When we substitute these in, do we ever get a negative answer? And we do, right? When you plug in this negative number, this is going to be a negative number, and so is this one, and we can do that. And so 4.112 is our solution. It would be a great idea for you to actually verify that this is true. You're going to have to use the change of base formula. Let's go ahead and do that. Log base 8 of 5 times 4.112 is 20.56. and I'm going to add log base 8 of 3.112. So remember, I have to use my change of base formulas there. Log of 20.56 divided by log of 8 is 1.4. I'm going to switch colors here so we can kind of see it. 1.454. And log base 8 of 3.112. Remember, we have to use the change of base formula. Log of 3.112 divided by log of 8 is 0.546. And these things do add up to 2, right? Which is the whole point. We're verifying that these things add up to 2, and they do. All right, let's do one more of these. Same idea. This one I think should be a little easier. We have multiple logs. We need to start off by condensing them. We have a condensing property. It says that when you are adding with the same base, base 4, we can condense them to be the same base, log base 4, of, and then you multiply these things, which would give us x squared plus 12x. At this point, we should know what undoes log base 4. The inverse of log base 4 is 4 to a power. If I do it to one side, I have to do it to the other side. They cancel here, and we get x squared plus 12x is equal to 64. I'm going to subtract 64 on both sides to get x squared plus 12x minus 64 equals 0. Now this looks a little bit easier to factor. 8 won't work, obviously. What about 16? 16 and 4, right? Remember, factoring, you're looking at, hey, what multiplies to 64? That adds to positive 12. That would be an x plus 16 and an x minus 4. So we would have negative 16 or 4, but that's not going to be our answers. We have to verify that they both work. And negative 16 would make them negative numbers, and you're never allowed to take the log of a negative number. However, 4 does work. We're making positive, and so 4 is our solution. Negative 16 was extraneous, but 4 works. I hope this makes sense. Please check into my office hours if it does not, and we will get this sorted out. Thank you.